Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on Wronskian, lecture number 3, in which I will describe the role of Wronskian for the solution of homogeneous linear differential equation when one particular solution is known. Now we prove a theorem. Theorem is, if y1 be one particular solution of a second order homogeneous linear differential equation, then it may be possible to find the general solution of the differential equation. Now we prove this. Let y1 be some known particular solution of the second order homogeneous linear differential equation y double prime plus a1y prime plus a2y equal to 0. Let this is number 1. Implies that y1 double prime plus a1 y1 prime plus a2 y1 equal to 0. Let this is number 2. Let y2 be another particular solution of equation 1 such that y1 and y2 are linearly independent. Therefore, Wronskian W for y1 and y2 is non-zero. Implies that W equal to determinant of y1, y2, y1 prime, y2 prime. y1 prime means derivative of y1 with respect to x, and this is not equal to 0. Implies that W equal to y1, y2 prime minus y1 prime, y2 not equal to 0. Let this is number 3. From Liouville's formula, we know that W equal to C e to the power integration minus a1 dx. Implies that W means y1 y2 prime minus y1 prime y2 equal to C e to the power minus integration a1 dx. X be the independent variable. Implies that y1 y2 prime minus y1 prime y2 by y1 square equal to C by y1 square e to the power minus integration a1 dx. Implies that differentiation of y2 by y1 with respect to x, x be the independent variable, equal to c e to the power minus integration a1 dx by y1 square. This is number 4. Integrating both sides of 4, we get y2 by y1 equal to integration of c e to the power minus integration a1 dx by y1 square dx plus a constant c prime be a constant. Constant means arbitrary constant. Implies that y2 equal to y1 integration c e to the power minus integration a1 dx by y1 square dx plus c prime. This is number 5. Since y2 be a particular solution of 1 which is linearly independent with y1, so we may choose c equal to 1 and c prime equal to 0 in 5. Hence 5 reduces to y2 equal to y1 integration. Here c equal to 1, so we get here e to the power minus integration a1 dx by y1 square dx plus 0. This is number 6. Since y1 and y2 are two linearly independent particular solutions of differential equation 1, therefore y equal to c1 y1 plus c2 y2 will be the general solution of 1, where c1 and c2 are arbitrary constants. Therefore, y equal to c1 y1 plus c2. In place of y2, we write the value of 6, y1 integration e to the power minus integration a1 dx by y1 square dx, which is the general solution of differential differential equation 1. Here we see that in general solution we have only values of y1, which is the known particular solution of the differential equation 1. Therefore, we may get general solution of a second order linear homogeneous differential equation if we know one particular solution of that differential equation. And here the Wronskian plays an important role for getting this solution. Now we give an example. Example is, find the general solution of the differential equation 1 minus x square multiply y double prime minus 2xy prime plus 2y equal to 0 if one known particular solution y1 equal to x. Now we solve this. The given differential equation be 1 minus x square multiply y double prime minus 2x y prime plus 2y equal to 0. Let this is number 1. We may write this as y double prime minus 2x by 1 minus x square y prime plus 2 by 1 minus x square y equal to 0. Let this is number 2. Given that y1 equal to x be a particular solution of this differential equation, that means if we put y equal to x, then this equation will be satisfied. Let y2 be another particular solution of this differential equation such that y1 and y2 are linearly independent. Since the differential equation 2 is of the form y double prime plus a1 y prime plus a2 y equal to 0. Let this is number 3. Therefore, a1 equal to minus 2x by 1 minus x square. Let this is number 4. a2 equal to 2 by 1 minus x square. This is number 5. Therefore, y2 equal to y1 integration e to the power minus integration a1 dx by y1 square dx. Here y1 equal to x and a1 equal to minus 2x by 1 minus x square. We put these values, we get this equal to y1 means x integration e to the power minus 2x by 1 minus x square dx by y1 square means x square dx. This equal to x integration of e to the power, here minus minus plus, integration of 2x by 1 minus x square is minus log mod 1 minus x square by x square dx, implies that y2 equal to x, here e to the power minus log modulus of 1 minus x square. We know that a to the power x equal to e to the power x log a. Here in place of x we have minus 1 and in place of modulus of 1 minus x square is a. Here in place of a is modulus of 1 minus x square and in place of x minus 1. This means 1 by modulus of 1 minus x square. Here e to the power minus log modulus of 1 minus x square equal to 1 by modulus of 1 minus x square. So here we write y2 equal to x multiply integration of 1 by this x square and then 1 by modulus of 1 minus x square and dx. Now we write this in partial fraction, we get this equal to x integration of, here plus minus 1 by x square plus 1 by 2 1 minus x plus 1 by 2 1 plus x and dx. We integrate this, we get this equal to x integration of this is minus plus 1 by x and integration of both these two be half log modulus of 1 plus x by 1 minus x. And if we multiply x with this term, we get minus plus x multiply 1 by x equal to 1 plus half x log modulus of 1 plus x by 1 minus x. And we rearrange this. We write this term first and minus plus 1 in second position. So we get y2 which is linearly independent with y1. Now we get y1 and y2 two linearly independent particular solutions of the differential equation. Then general solution will be y equal to c1 y1 plus c2 y2. c1 and c2 are arbitrary constants. Since y1 equal to x, so we write c1 x plus c2 y2 equal to this right side of 6 and we get the general solution. Therefore, if we know one particular solution of a second order homogeneous linear differential equation, then we may find the general solution of the differential equation. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.